Yep, we can. Okay, perfect. So then let's get started with a short introduction. Since you asked, Greg, my name is Bas Land. That's a difficult name to pronounce in English, I know. It's the shortest name that you can get, but nobody knows how to pronounce it, at least not in English-speaking countries. I've been a data consultant in the Microsoft space since 2013, seen quite some technologies from SQL Server, Power Pivot in Excel, all the way to Azure SQL, and for the past couple of years, it's been Fabric. I'm a partner in Kimura. We are a data and AI software and consultancy company here in the Netherlands. We do work mainly with Dutch clients and some work across Europe. Not in Australia though. I would like to visit one day, but that's not been happening as of now. And since last year, I hold my MVP award in the data platform category. And as of yesterday evening, my time yesterday evening, probably your midnight, I was re-awarded with the 2026 MVP award. So that's actually really nice. And I'm a Brazilian Jiu-Jitsu brown belt. I lift weights and I run because sitting behind a laptop doing Fabric all day, that makes your back hunch a lot. That's not really healthy for you, I guess. So I like to play sports. I like to fight a bit, and then you say fighting, it can be wrestling, like you wrestled your dad and your brothers when you were young, but then this is for grown-ups. So, and I'm a husband and a father of this little guy. We had a lot of snow, and the little one was enjoying that quite a lot, as you can see. And then diving into the topic of today, I will be going through a little bit of theory and setup prereqs that we need to think of, and then we just dive into a live demo because I always think demos are more interesting than slides. But to start, what are Fabric data agents and why do we say that dashboards are dead? With dashboards, I mean, you all have built dashboards, right? You know Power BI, that's out for, what is it, 10 years, 11 years now? And before that we had other dashboarding tools. So we all know what dashboards are capable of. And they are really great for answering questions. However, these questions are usually questions that we have to think of in advance. So we need to think about what is my user going to ask next week or next month, and can I answer that question using data in a dashboard? That limits the user inquiry that we can work with. That makes it an ongoing process, that if your user gets newer questions, they might come back to you and say, okay, can you develop a new dashboard, or can you add the page to this Power BI report? And that means that you get this process up and running that is very repetitive. That takes a lot of time, and that's maybe not as user-friendly, especially in larger organizations where we have a too small data team with too many users that are asking questions, and you have this massive multi-month backlog of to-dos in Power BI. If you have a repeatable process, however, this is really good. So when you have a dashboard that is being looked at every week or every month, answering the same questions, perfect. Power BI is the way to go, and you should use a dashboard for that. On the other hand, there is a lot of upfront effort that we need to put in creating dashboards because we need to sit with the user, we need to take time understanding the requirements, we need to find the data in our data warehouse or somewhere else, and that takes some investment upfront in time and or in money. And also, there is not that much context in a dashboard. And now I understand that you can go from a dashboard into analysis, into report level data pages with Power BI, but it is really hard to bring a lot of context around data or a business process into Power BI. And that hinders deeper understanding for the user. So it is difficult for them to draw in context from just outside of their scope or their process in order to really understand what's going on. And that limits the discovery and the insights that we can derive from these dashboards. So we now have data agents, and then everything is right in the world. What are data agents? They are just an interface to communicate with your data, to consume your data. Just like Power BI is an interface to consume data in a semantic model, in a database, in your Fabric data lake. The data agent is the same thing. It's an interface that you can use to consume data in a chat-like fashion. So we're not looking at charts and graphs, we're just talking to the data like we're chatting with a colleague in Teams. We can ask these questions in natural language. So when we do SQL or DAX, we need to think of what is the data structure and what syntax do I need to put in, and do I join and filter correctly and aggregate correctly. With data agents, we can ask questions in English and get an answer. There is minimal setup required to set these up, and we're going to look at that today. We're going to build a data agent from scratch. Given that we already have the data set and the semantic model in place, we can, in just mere minutes, we can create a data agent. We will be looking at the importance of a proper setup. Even if it takes very little time, we do need to think about a few things that are important for proper use around security, around what data sources can we use, around instructions to the agent, and so on. And we're going to look at what data combinations we can make, where the data agent is being able to not just pull data that is very highly refined from the semantic model, for example, but also from the underlying data lake, and also from just general knowledge around things that happened in the world that might not happen, that might not be in your data lake, but that are common knowledge. And I think that is a very how do you say that? That's a very strong pro of using an agent versus a dashboard. Now, I've been saying this already, right? Agents are not necessarily a replacement for dashboards. So what is really great about the agents versus a dashboard is it improves your data discoverability by simply asking a question, getting an answer, and then being able to ask follow-up questions. I mean, you're all playing with Copilot, with Claude, with ChatGPT. You know how to interact with these agents, or with these chatbots, I should say. That's really cool. You can now do that with your data set inside such a chatbot. That interactive querying that makes that you can get answers much faster, and that you don't need to call your colleague. Maybe your colleague knows all about some process or some KPI, but you don't want to take half an hour of their precious time if you can ask the agent. And you have this very limited setup. Now, there is some downsides to using chatbots as well, or to using AI as well, of course. There is no deterministic repeatability. And that means that if we have a dashboard with a data set with tables and relationships and DAX measures, then the outcome of those measures is very deterministic. We know that if we put a certain piece of data in, we do a certain calculation, there is this answer that comes out. That's deterministic. That works all of the time, every single time, so we can predict the outcome and we can validate the outcome really easily. With AI, we all know it's not deterministic, it's probabilistic, and that means that every time we put something in, we might get a slightly different answer. And that's not really a problem if you are using data agents for discoverability and for finding out what can we do with our data, or you're using follow-up questions for ad hoc analyses. But if you're using data agents for something for some process that you want to track every week, for example, then maybe this would not be the best solution. And then, of course, we have AI hallucinations. I have the feeling they are occurring less and less these days, but still we have all seen cases where AI is very confidently presenting you with a wrong answer. And only when you tell it the answer is wrong, it says, oh yes, sorry, my bad, this is actually the correct answer. That happens with data agents as well. If you're used to working with ChatGPT, data agents is using the same model. So the OpenAI GPT-5 model family is being used by Fabric data agents in order to present you with answers. So all the prompting, but also all the hallucinations that you will find in ChatGPT will probably be in Fabric data agents as well. Now, we have a lot of data sources in Fabric and in OneLake that we can use to build our data platform, our data lakes, our warehouses for semantic models, but also KQL databases for streaming analytics. We have ontologies these days. And all of those data sources can be going into your Fabric data agent. I think there might be more being added. I think SQL database in Fabric is now added as well very recently. So probably there's more than just the 5 that are listed here. And at any given time, you can have 5 data sources active in your data agent. That is not necessarily the 5 that we have here. It can be 5 lakehouses or 2 semantic models and 3 warehouses, for example. But you can have 5 data sources that are active in your data agent. Now, the process, if we start interacting with our data agent, we ask a question in natural language. So we write in English, what was my revenue last week? Then the agent is trying to guesstimate what the best data source is to answer your question. It does so by understanding the metadata of your data sources. It also does so through any instructions and sample queries that you've given the agent during the setup phase. That's something we're going to look at in the live demo. And based on those estimates, it will pick the right data source. It will either go to the semantic model or to the data lake or whatever. Then it will generate a query to that data source it just picked in the previous step in order to translate your English question into a structured data query against semantic model using DAX or against data warehouse using SQL. And it will fetch a result set. That's in between the query will be validated for accuracy, for permissions, for validity, and so on. And once the query is being validated, it will be executed against that selected data source. And the result set from the query will be fetched back into the data agent and will be summarized, and then you will get a response either in plain text or, these days, this is all quite new, in a chart or graph. Now, the round trip here between English language to query to data source and back into language is something that's handled by the data agent and that you are paying for through the data agent. So the data agent is actually the Fabric artifact that you are paying for, that you're consuming CUs for in your Fabric capacity. The actual fetching of the data and executing of the queries that are being generated, that is built to the underlying data storage. So that means that if you have a Fabric lakehouse and you write a Spark SQL command into the lakehouse, you read using a Spark SQL from that lakehouse, then the lakehouse operation is actually consuming CUs for fetching the data and executing the query, and then putting in the English question and the English answer that you get from the agent. That is built as CU usage on the agent artifact. And that also means that you need to think about what types of questions am I going to ask. So maybe I can do a pre-aggregated, pre-filtered semantic model that is very tailored to certain types of questions. Then I have my warehouse or lakehouse below that contains all of the data that is in scope for this agent. And I'm going to tell the agent to prefer the semantic model as much as possible, because it's way cheaper to fetch data from the semantic model than from the very detailed lakehouse. That could be an optimization that we're trying to put in place. Now, of course, with AI, we have to think about checks and balances. One of the big things is we need to respect user access, row level security, object level security, and so on. If we are using RLS in the Power BI semantic model and we are reading data from the semantic model, the agent is respecting that. So it can be that we're both interacting with the same agent and that we're seeing different results because we have different underlying row level security access to the semantic model. I believe this now, but I've not tested this recently. I believe it also should work for OneLake security, row level security, that we can put in place on the lakehouse tables, on Delta tables in your lakehouses. Then we have the responsible AI checks, and these are put in place maybe not by the Fabric team in data agents, but more by the model creators over at OpenAI, where automated decision-making, criminal activity, and so on is not allowed. So just like with Copilot, ChatGPT, and Claude, if you start asking it to create a bomb, it will tell you, no, I'm not going to help you with that. The same thing happens for data agents. And then again, one thing that is skipped over usually, but is quite important, everything that we do with the data agent is read-only. So the agent to data source connection is a read-only connection. So even if the agent would hallucinate, would create an update script in SQL, it will not be able to change data in the underlying data source. But we can only read data from those data sources. That makes us all sleep better at night, that users are not able to change data by clever prompting in the data agents. A few prerequisites that we need to put in place before we can actually start, and that is that we need to have a Fabric capacity to use Fabric data agents. Now that might sound like something that is very obvious, and it is. However, there are some requirements to these capacities. It needs to be a paid capacity. So we can use the smallest capacity possible, an F2 capacity. We do not need F64 or anything like that. With a very small capacity of F2, we can use data agents. However, it needs to be a paid capacity. So if you are on a trial Fabric, an FT4 or an FT64, you will not be able to use data agents. When we were talking to Microsoft about this, they said, well, we simply don't have the GPUs lying around to give away AI for free. So that makes sense, I guess. There is a big demand on data center hardware in Azure and especially on GPU power. So we need to be on a paid plan to use the agents. If we want to use semantic models as a source, we need to have the XMLA setting enabled so that we can communicate through XMLA with our semantic models, because that's what the agent is using. And in our Fabric or Power BI tenant settings, we need to enable the cross-geo AI processing. And that means as much as that we are trying to process your data in the region that your data lives in. However, because of constraints on compute power, it can be possible that Microsoft is relaying your question to an AI component in a different region. And that can be a problem, or it is not necessarily a problem. That depends a bit on jurisdiction, on the type of data that you're processing, and so on. Now, I know that in the EU, there is very strict privacy laws against processing personal identifiable information outside of the EU. That's actually illegal. So if you process names, birth dates, addresses, and so on for private persons, for companies it's okay, but for private persons you're in trouble. If you process that outside of the EU physically, that's illegal. So you have to think about, do I want to put this setting on or no? It's a risk evaluation that you have to do there. Of course, if you live in a jurisdiction where this is not a problem, by all means go ahead. And if you think, okay, but I only process company data about products and orders and other companies, then you should be fine probably. But at least be aware that you need that cross-geo setting enabled. And now it's demo time. This is the most interesting thing that we do, of course. So let's head over to Fabric. Let's double check my capacity is up and running. I do have, as we can see here, I do have an F2 capacity because I don't like paying a lot of money for these demos. The capacity is running, so we should be able to go. Let me zoom in a little bit and let's open an existing data agent called Taxi Analysis. You probably have seen the New York City Taxi and Limousine Company, the TLC taxi data set. It's, I think, 4.5 billion or 5 billion rows these days. It's being added to every month by the city of New York. And this is a very nice, large volume open source data set that you can download files from to use in your own projects. So that's what I'm using here as well. Right now on the screen, we are looking at the data agent from my perspective as the developer of the agent. And we see a few different things on the screen. I'll talk you through what we see here. Then we will be asking a few questions to the agent, and then we will start setting up the agent from scratch together. Now, over on the left side in the Explorer, we see data setup and tools. Under data, we find the data sources that are connected to this agent. We can find one lakehouse here and one semantic model here. The semantic model is called Taxi Data Agent, and when I open it, I can find which tables are in the model and which tables are exposed to the agent. So right now, all 4 tables are exposed to the agent, but we can disable, for example, this particular table. So the table is in the model, but I do not want to expose it to my agent. In this case, that would not work. So let's quickly re-enable it again. And once we This is so nice to have a scroll bar here that doesn't let you scroll. That's really cool. And once we, no, that doesn't really make any difference. Once we open the table, we can find out what types of DAX measures are in this table. So we have number of trips, number of passengers, average trip distance, average passenger count, I think, and total trip distance. And we can analyze it across taxi types, locations, which is linked to the pickup location in this example, and a date dimension. So this is an aggregated dataset, by the way. It's aggregated by pickup location, by taxi type, and by day. And it can answer some questions that we might have around the usage of taxis in New York City. Then we have the lakehouse, and in this lakehouse we have a few tables. And let me quickly check whether this was due to the, yeah, it was due to the zooming. In the lakehouse we have a lot of tables, and this is my demo lakehouse, so you see a lot of crappy table names in here. And I've chosen to expose a few of those tables to my agent. So only the checked tables are actually being consumed by the agent at this point in time. And here we have my fact taxi data table that contains a row level information per taxi trip, I think from 2009 up until 2024 or something, which is a 4 billion line data set with a couple of dimensions around dates, times, pickup locations, drop-off locations, and taxi types. So we have a very nice data set in here to start querying our agent. And we can very easily now start asking things like, what are the top 5 locations in Manhattan that originate taxi trips to Brooklyn in 2022? Now it's going to think about my question. It is going to predict what data source it should refer this question to. Then it's going to generate and validate the query, execute the query, get back a result set, and then it will be able to tell me the top 5 locations in Manhattan where taxi trips to Brooklyn originate. Now we are seeing here that while it is busy, it is rephrasing my question. So it is adding it's adding some reasoning where it says list pickup zone names with the total number of such trips, because that will be used to then sort by trip counts, I would guess, in order to give the top 5 pickup locations. We also saw that when we open this one, we see that here already, it has been analyzing the lakehouse and not the data agent. Why is it analyzing the lakehouse? In this case, it's analyzing the lakehouse, not the semantic model, because the taxi trips in the semantic model only contain pickup locations. So we see where the trip was originated. We do not see the destination of the trip. And I ask it to give me the origination location, the pickup location, with a certain destination. So in order to do that filtering, it needed to fall back into the 4 billion line fact table in the lakehouse. Now within 27 seconds, the result set came back, and we find here that these were, in 2022, the top 5 number of locations. If we want to understand why did we get this answer, we can open the reasoning step here. And we will find out that there is a SQL query that is being executed against the SQL Analytics endpoint of this lakehouse in order to actually find the number of taxi trips. And what we see here is that the pickup zone and the trip count are being selected from the fact table. There is a join to date because we need to filter on calendar year. And there are joins to the pickup and drop-off locations because we need to filter for the boroughs, Manhattan and Brooklyn. I did not tell it to filter for the borough. It understood that by itself from context of the conversation, because it understands that Manhattan and Brooklyn are actually boroughs in in New York. And it understands that there is metadata such as column names called borough in these tables. So that was all quite good. The result set that has been coming back looks like this. It's of course just a table, and then that table is being, there we are. The table is then being parsed into an answer that I get in the chatbot. What's new in data agents is that we can generate visualizations as well. So we can now ask for, trend lines of trip counts 2019 by day. Now I think we should be getting a query against the semantic model. There we are. This is the semantic model. That's actually cool. Total number of taxi trips per day, suitable for trendline visualization. And it should be understanding that it's supposed to produce a line chart. Too many data points. And we can just keep chatting with the model. What type of data did it actually get? I mean, this is not too bad. It should be 365 records, right? It should be easy to visualize. Anyway, now the monthly one should be a little bit easier for the agent to understand. There we are. Let me zoom out a little bit to make this visual. Here we have a brilliant trend line analysis of taxi trips by month in New York City in 2019. Now, how did we get here? We get here through adding data sources to the agent. So we can go here to add data, add the data source, and then any data sources that I have access to in my tenant, I can add to the agent. Then when we have added those data sources, we select which tables we want to see or which tables we do not want to see, and then we go to setup. Now under setup we find agent instructions, and then for our lakehouses and warehouses we find data source instructions and sample queries. We do not have data source instructions and sample queries for semantic models, but we do for the lakehouse in this case. Now under agent instructions, we can put in information about how we want the agent to behave. Okay, and this is quite important. Microsoft, in their documentation, they tell you to use an objective, data sources, terminology, response guidelines, and so on. And one of the things that I usually put in here is do not steer off topic, only respond to questions about, insert the topic of your data agent here. The reason is this is a GPT-5 model and it will happily create a rap song for you about apple pie recipes. It is super easy to do that because ChatGPT will do that. The GPT-5 model family will easily do that. And Fabric Data Agent is no different there. However, it is consuming very expensive fabric capacity by doing so. So you can tell the user to not do that using Fabric, just do that using ChatGPT instead. This will help the model understand the context it is operating in. So you should think about what you can put in here. The more context you put in here and the more specific you are, the better results you will be getting from your agent, of course. So while it's super easy to spin up a new agent, just put in your data sources and be going, it is worth your time to think about the instructions for an hour or two. And maybe not an hour thinking about this here, but also about your data source instructions, your sample queries, and so on. So about the data source instructions, when we go into our lakehouse, we can tell the engine here what the lakehouse is all about, what we do have in our gold lakehouse in this case. Where I told it to think about the lakehouse as containing very granular and high volume data on taxi trips between 2009 and 2024. This will help the agent to tell me that if I ask for 2025 taxi trips, it will tell me I don't have the data. Instead of it generating a query, spending tokens, billing me, then executing that query against the lakehouse, again, spending CUs on the lakehouse, and then saying, no, there are no results. It now should understand from this context that there is no 2025 data. And we tell it that we have data on individual trip records, and we can use it to answer questions on blah, 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 right? Again, put in anything that you would like to tell the agent. Now, we have some data source instructions that we could put in here. I usually put in table descriptions, especially around PU and DO for pickup and drop off. You see here that we explain what that actually means, all right? And when asked about the relations, we should follow the relations between tables. You can join the fact table to the goal din times using the pickup time field, blah, blah, blah. So we give it samples of what it can do. Again, we also say, be aware this dataset is large and slow, and it should be using the semantic model as much as possible. So then again, this instruction is being used during the evaluation of our question when it's trying to guess which data source is the best for the question that we have. Now, in case the semantic model in our agent cannot answer the question, the model will actually fall back to the lakehouse, and that's what it's designed to do. And when doing so, I want it to write really good SQL queries. And I can make it write really good SQL queries by giving it pairs of questions in English and queries to answer that question in SQL. I've included two of my sample queries here, which is in 2023, what are the most common pickup and drop-off zone pairs with trip count, average distances, and average tips. And there is this SQL query that we use in order to actually get the answer to that English question. And we do the same thing here with another question where we get the unusually high tips compared to the expected tip amount for that trip distance. This is a more complex query, and in here we have a lot of information, a lot of context about the shape of our data. So when we can parse the English query, the English question that we send to the agent, we can find all kinds of different things in there, and the AI model can find all kinds of different data points in that question, and then it can link those to the SQL query that we have here. So it's, for example, it can find what are the relationships between tables. It understands that we can create these joins. Also for other questions, these are the joins apparently that we can create. If I say in 2024, I mean the calendar year in the date dimension. If I look at the tip amounts, then the tip amount should not be empty. The trip distance should be larger than 0 because there are data quality issues in this data set with negative trip distances. So we want to omit those from the query. Now, all of this information is being taken into account when the AI is generating queries to answer our questions. So use the agent instructions, the data set instructions, and the sample queries to enhance the quality of your analyses. Then in order to test, we can here hit clear chat, and we say yes, clear the chat, and we can start asking questions. Tools is new. We can add user data functions, for example, to the chat as well, or to the chatbot. I've not worked with those, so I cannot show you anything there, but we can use these Fabric UDFs in our agents these days. Now, let's create our own agent, and just to show you how easy it is to do so, Here we go. We pick data agent and we say Melbourne meetup. There we are. We have an empty agent in here. We first need to put in a data set. Let's put in our data source taxi data agent. Let's add that one and give it access to all 4 tables. And let's also add the gold lakehouse. Let's find it here. I have 2 lakehouses that are called gold. Okay, now I hope that I picked the right one. For this part of the demo, it's not a big issue if it's the wrong one, by the way, but it looks like this worked. Let's do dates, locations, taxi types, times, and this one. There we go. Now let's just ask any question just to test whether the agent is working and responding. It is now falling back to the semantic model. That's actually good, that without me putting in any setup in here, I mean, the instructions here are empty. These instructions are empty. There's no sample queries. So without doing anything there, this is actually doing really well. And the most distance covered was in 2014 with a 2 billion mile trip distance. All right, that's cool. Now give me a rap song about taxis in the style of Snoop Dogg. Let's see if it wants to do this. It probably will, because again, we did not put in any instructions, and we are, there we are. This always gets a big laugh in groups. So we are now clearly seeing that we are chatting just with a very generic GPT-5 model, right? This is not something very special or specific that's created and highly tuned by Microsoft in order to do data analysis. This is just plain old GPT. And as you can see, it will answer questions about anything like ChatGPT also would. Now, again, I am paying Fabric capacity for the tokens that I'm consuming here. So maybe this is not the smartest thing to do. However, we can see that this is clearly the behavior of the agent if I do not tell it otherwise. Let's put in the markdown, use this to analyze taxi trips. Do not go off topic. If the user wants to go off topic, tell it to use ChatGPT or worse, Copilot. All right, can you give me an apple pie recipe? Let's see what's coming up right now. There we are. It is steering away from the Copilot comment, but it's telling me to use ChatGPT or another assistant focused on general topics. So with just that one line of agent instructions, we can actually put in a guardrail against the misuse of our data agents, right? Now, for the demo, this gets laughs in the group. This is all fun. But if you're deploying your data agent inside Fabric to a large company with maybe 1,000 users or more, you have to be very specific about what you want the agent to do. So what I said is, it is super easy to start up an agent, right? We have the semantic model, we have the data lake, we click new agent, and basically we are up and running and we can start asking questions and getting answers about trip distance and every metric that we can think of that are in the semantic model. So creating these is super, super easy. You do not need to sit with your users for interviews. How do they want to visualize their data? What questions are they asking? What story am I telling with my data? There's none of that. So you're very quick to create an agent. However, you have to think about what do I want the agent to do and what do I not want the agent to do. I do not want it to create rap songs or apple pie recipes. So I need to tell the agent to stay on topic. That is just one example of some of the boundaries that we have to put in place. But it also shows that we can very easily control what the agent is doing by using the setup, by using any of the instructions here. Of course, this is just telling the agent, do not go off topic. This is a hard line. I do not want you to do it. Some of the more nuanced instructions that we can put in are things that I had in my pre-built agent, which is about use the semantic model unless you cannot answer a question using the semantic model. By the way, the semantic model contains these tables, these metrics. You can use it on this aggregate level. And if you need more data than that, a more detailed grain or more metrics that we do not have in the semantic model, only then go into the lakehouse. By the way, here are some sample queries. So you can make your instruction set as broad as possible, but at least be aware that you need these instructions in order to have a better working model that is, one, cheaper to use, and two, gets you better answers. That's it for the demo. Let's do a quick recap. We've seen that data agents are quite cool for data discovery. If you do not know what you want to know, and you have some ad hoc questions or some analysis that you want to do, or you just want to be digging through your data, then of course you can open SQL Server Management Studio and you can start querying your dataset. You can open Power BI and start putting in data on your canvas. You can also start asking questions about your data, getting an answer and putting in follow-up questions. And that last thing, that's something that I like to do a lot. Setup is important, as we have just demonstrated, and we need to validate responses. So if you start creating data agents, open up the reasoning step. Actually try to understand what it is doing, what queries is it generating, and if you spot mistakes there, go back into your instructions, or especially in your lakehouses and warehouses, go back into your sample queries, because that will create a very high level or high accuracy model. The AI can and will hallucinate from time to time. Do not trust it blindly. I guess the same goes for Power BI reports, where the Power BI developer might hallucinate from time to time, and they might put in filters that do not work, or DAX measures that have edge cases that do not work as expected. So even those we should not trust blindly, but at least those are deterministic. With AI, it's probabilistic, and we have to understand that we cannot just do blind trust in AI. Thank you so much. Follow my YouTube. This is an older screenshot. I'm approaching the 1,000 mark in subscribers now. And every week I'm publishing videos on Power BI and Fabric. I love talking to you guys. And if there's any questions, let me know.